into angle properties. Now that you know how to solve equations, you're going to find that solving for missing angles is going to be a lot easier. So before we get into this part of our unit, it's important for us to go through some definitions. So these are important definitions, and this is going to be a great handout to refer to as you do the next two lessons in this section. So an acute angle is an angle that is less than 90 degrees. A right angle, you will remember from when we did Pythagorean theorem, is an angle that equals to 90 degrees. An obtuse angle is an angle that's greater than 90 degrees but less than 180 degrees. And there are two other angle definitions that you're going to need to know. The next is a straight angle. And you can see from the picture it's a straight line. So the angles on a straight line equal to 180 degrees. And the last angle definition you'll need to know is a reflex angle. This is an angle that is greater than 180 degrees but less than 360 degrees. So now that you have these angle definitions, we're going to take a look at some triangles. So within this angle lesson and unit, we're not only going to look at definitions of angles and how to find missing angles, but we're also going to look at angles within polygons. So whether those are triangles or quadrilaterals or any other multi-step or multi-sided shape. So triangles can be classified by their angle measurements and their side measurements. In grade 10, you're going to start to look at trigonometry, and you're going to look at that even further when you look at in grade 11. So it's important that you understand different types of triangles and their classifications. So the first is a right angle triangle. So this is the triangle that we looked at when we did Pythagorean theorem. And you'll notice that a right angle triangle obviously has a 90-degree angle. So that's shown by using the little square in the corner to show that these two lines are perpendicular to each other. Another type of triangle is where all three of your angles are different, and we call that a scalene triangle. And two other triangles that we're going to take a look at when we're looking at angles is when we have two angles that are exactly the same. As we can see here, we have two angles that are equal to 50 degrees. We call this an isosceles triangle. And the last one is where all three angles are exactly the same, so they all add up to 60 degrees, and we call that an equilateral triangle. So triangles can, as I said, can be classified using their angles, but they can also be classified using their sides. And that's going to be very important for us as well. So you'll notice that when we look at the next page of this lesson, we have triangles, and some of their names will be similar to what you have when we looked at angles, because that's going to be very important as well. So triangles can also be classified by their side lengths. So if every single side is different, just like every single angle was different, this is a scalene triangle. If two of your sides are the same, just like two of your angles were the same, this is an isosceles triangle. And if every side of your triangle is the same, like every angle of your triangle is the same, it's an equilateral triangle. And so these properties are important. So if you have a scalene triangle where all three sides are different, then all three of your angles are also going to be different. If you have an isosceles triangle where two sides are the same, it also means that two angles are going to be the same as well. And if you have an equilateral triangle where all three sides are the same, that means that all three angles are going to be the same as well. So that's important. So within looking at triangles, we're also going to look at some other definitions of angles that are going to be very important for you as you move forward, especially when we get to not only solving for missing angles, but when we start to look at angles involving parallel lines as well. So again, this is going to be very handy for you to refer to as you progress through this unit. So the first angle that you're going to need to take a look at is complementary angles. So these are angles that add up to 90 degrees. And you'll notice within these examples, I show the right angle. That's very important. So if you don't see that right angle, then we can't assume that it's a 90 degree. So as you go through this unit, you have to trust that the diagrams probably aren't to scale, but also if it doesn't really specify that it's 90 degrees, you have to take that into consideration as well. So what this means is that if I have a 90 degree angle and I split this up into two angles and I label one X degrees and I label the other Y degrees, that X plus Y is equal to 90 degrees. That's important. So that's something that you're going to want to know and refer to. Now, there are different ways that you can express these angle properties, or that you can express angles. So one is just by labeling the actual angle itself with a letter, like we did here. Or another way is that you can distinguish different angles is by using letters on the vertices of your lines. So if this was my right angle triangle, or my right angle, I'm going to redo that. Okay. And I want to label the edges of or the ends of my line. So I'm going to have A, B, C, and D. So we can also label angles using the letters that form that angle when making sure that the corner or the middle of our angle is always in the middle of our lines. So I can also say that angle ABC, so these are the letters that make that angle, and we use that by using a little symbol that sort of looks like a less than symbol. So angle ABC plus, and then I can do this one CBD. So angle CBD is equal to 90 degrees. So those are two ways that you can represent angles. So just a letter within that angle, or letters that represent the corners. So that's important as well. So let's take that information and solve for these missing angles. So if I want to find the value of y, well, then I want to take I know that y plus 38 is equal to 90. So then this becomes an algebra question. So I know that I need to move over my 38, and right now it's being added, so I'm going to subtract it. So y is equal to 90, take away 38, and then it becomes an arithmetic question. So you can do this using mental math, or you can use a calculator. So 90 take away 38 is 52. So the value of y is 52 degrees. So make sure that when you are solving for angles, you use the angle symbol in your final answer. For part B, I know that each of these angles, when I add them together, is going to give me 90 as well. So I have Z plus 42 plus Z is equal to 90. So I'm going to combine my like terms. So I have two Z's. So 2Z plus 42 is equal to 90. You'll notice that for the Z's, I put a little line in the middle so I don't confuse them with my 2's. And now I want to solve this using what I know about solving equations. So I'm going to move my 42 to the other side and subtract it. So I have 2Z is equal to 90 take away 42. And 90 take away 42 is 48. So 2Z is equal to 48. And now I want to divide both sides by the coefficient in front of my Z. So 2 divided by 2 is 1, so I'm left with Z, and 48 divided by 2 is 24. And this is an angle measurement, so I need to include my angle sign. So Z is equal to 24 degrees. So that's why knowing what we know about solving algebra is going to be very handy to this equation. So now what I want to look at is supplementary angles, and supplementary angles add up to 180 degrees. So any line on a straight line, if I break this up into 2 angles or 3 angles or 4 angles, when I add these two together, they're going to equal 180 degrees. So if this was my diagram, and I have x here and y here, then x plus y is equal to 180 degrees. So remember, you can represent them like this, or you can represent them as letters that we did up there in the first one. So let's take this property and solve for our missing angles. So I know that k, because this is a straight line, so k and 57 degrees will equal 180 degrees. So k plus 57 is equal to 180. So now it becomes an algebra question, which I know how to solve. So I'm going to move my 57 over to the other side and subtract it. So k is equal to 180, take away 57. And using the tools available to me, as a calculator, for example, I can solve that k is equal to 123 degrees. So example B, same thing, because these angles form a straight line, that each of these angles, when I add them all up, will equal 180. So I have y plus 81 plus 24. All three of those will equal up to 180 degrees. So I'm going to simplify my terms. So 81 plus 24 is equal to 105. And now I want to take my 105 and bring it over to the other side of my equation and subtract it because I'm adding it to the left-hand side. So I have y is equal to 180, take away 105. And simplifying that gives us 75 degrees. So you'll notice that I'm always going to put my degree symbol in my final answer because I'm solving for an angle. That's very important. In order to get full marks, you have to show that you're solving for an angle. So just like when we did measurement questions, when we looked at perimeter, area, volume, we had to include our units. So think about this as a unit, right? So it's an angle. Another property that it's important for you to understand is what we call the opposite angles theorem. And so sometimes this is referred to as the X property when you're looking at angles, but opposite angle theorem is the actual mathematical term for these angles. So when lines intersect, And so when they cross each other, the angles that are across from each other are going to be equal. So if I was to draw a little diagram here, and I labeled this one X, and this one Y, this one Z, this one W, I guess, then I know that the angles right across from each other are going to be exactly the same. So W is the same as Y, and X is the same as Z. So that's what the opposite angle theorem tells us. So the angles across from each other are exactly the same. So if I'm looking at these examples, well, I can easily say that H must be 102 degrees because these two are exactly across from each other. They're opposite each other. And W must be 78 degrees because those two are across from each other. Okay, so that's helpful for us to know. When I'm looking at example B, same thing. I want to look at the angles that are directly across from each other. So V is equal to 63 degrees because those two are directly across from each other. N is equal to 58 degrees. And now, how do I find M? Well, if I take a look at these three angles here, all three of these will add up to 180 degrees. So these form a straight line. So M plus 58 plus 63 is equal to 180. So we're using the property that we learned in the previous example to help us out to solve for M. So I'm going to simplify my like terms so I can figure out what 58 plus 63 is. So that's 121. So M plus 121 is equal to 180. And now let's solve this using algebra. So I'm moving over my 121, subtracting it. So M is equal to 180, take away 121. So M is equal to 59 degrees. And you'll notice that I'm always using that degree symbol in my final answer. So that was a combination of opposite angle theorem and angles that form a straight line, which we call supplementary. Okay. So now we need to look at some angle theorems involving triangles. So we can have, what we have is the angle sum of a triangle theorem. So this tells us that all of the angles within a triangle add up to 180 degrees. So that's important to remember. So if I'm taking a look at example A, or if I want to draw a different generic example, and I label these A, B, and C, then A plus B plus C is equal to 180. So if you wanted to write that out, you can. So this is what the angle sum of a triangle theorem refers to. So the angles inside of a triangle will add up to 180 degrees. So now let's take a look at some examples. So I know that C plus 108 plus 50 is equal to 180. So then this becomes an algebra question. And we know how to solve algebra questions because we looked at those lessons earlier. So I'm simplifying what I have on my left-hand side. So C plus 158 is equal to 180. I'm going to move my 158 over to the right-hand side. Right now it's being added, so I'm going to subtract it. So C is equal to 180 subtract 58. So C is equal to 22 degrees. Now let's take a look at example B. So this is going to be a slightly more complicated example, but it's nothing that you don't know how to solve. So I know that each of these terms, when I add them together, will give me 180 degrees. So I have 2x plus 3x plus 20 plus 60. All of that equals 180. So I'm going to simplify my like terms or combine my like terms. So 2x plus 3x is equal to 5x, and 20 plus 60 is equal to 80, and that's equal to 180. And now I want to move over my 80. So right now it's being added, so I'm going to subtract it. So 5x is equal to 180 subtract 80, or 5x is equal to 100. And now I divide both sides by the coefficient in front of my x. So I'm going to divide both sides by 5. 5 divided by 5 is 1. So I'm left with x. And 100 divided by 5 is 20. So the value of x is 20 degrees. So then if I wanted to then go back and solve for each of these different angles, well, 2 times 20 is 40. So this one's 40 degrees. And 3 times 20, or 3 times 20 is 60, and 60 plus 20 is 80. So if I wanted to go back and solve for each of those angles, I could do that. So I hope that's helpful in terms of looking at angle sum of a triangle theorem. So the next property that you're going to need to know about is the angle sum of a quadrilateral theorem. So the angles inside of a triangle add up to 180 degrees. The angles inside of a quadrilateral will add up to 360 degrees. And it doesn't matter what type of quadrilateral that is. So whether it's a square, a rectangle, a rhombus, a trapezoid, a parallelogram, it doesn't matter. Or just bizarre quadrilateral like we have in these examples here. So if I have a random quadrilateral and I label each of these angles in here A, B, C, and D, that A plus B plus C plus D is equal to 360 degrees. So if I'm using that information to solve for my missing angle, or in part B, missing angles, I'm going to use that information that I know. So I know that D plus 100 plus 93 plus 26 is equal to 360. So I'm going to add up my constants. So 100 plus 93 plus 26 is equal to 219. So D plus 219 is equal to 360. I'm going to move my 219 to the other side of my equation, and I'm going to subtract it. So D is equal to 360, take away 219. And that's 141 degrees. So if we're looking at example B, again, it looks a little bit complicated, but this is not something that you don't know how to do. So we're going to approach it exactly like we approached example B in our previous example. So I have y plus 10 plus 2y minus 10 plus 3y plus 20 plus 70, and that's all equal to 360 degrees. So all of these added up gives me 360 degrees. So I'm going to collect my like terms. I have y plus 2y is 3y, and 3y plus 3y is 6y. Now I'm going to look at my constants. 10 take away 10 is 0, and 20 plus 70 is 90. So I have 6y plus 90 is equal to 360. So now this becomes an algebra question that's a little bit easier for me to solve. So I'm going to start by taking my 90, bringing it over to the right-hand side. Right now it's being added to the 6y, so I'm going to subtract it. So I have 6y is equal to 360, take away 90. 360 take away 90 is 270. And now I'm going to divide both sides by the coefficient in front of my variable. So divide both sides by 6. 6 divided by 6 is 1, so I'm left with y. And 270 divided by 6 is 45. So this is 45 degrees. So then if I wanted to go back and figure out what each individual angle is, so 45 plus 10 is 55 degrees. 2 times 45 is 90, and 90 take away 10 is 80 degrees. And 3 times 45 is 135, plus 20 is 155. So you can go back and solve those by substituting the value of y into those little equations. I didn't have enough room in this space to show all of that work, so I did that using mental math, but if you wanted to write out the steps, you can, substituting that y is 45 into these equations here. So the next theorem that you need to know is the isosceles triangle theorem, and we sort of touched on this when we looked at different types of triangles. So if you have an isosceles triangle and the two sides are equal, then that means that the angles two angles are also equal. So the angle that those two form isn't one of the angles that are equal, it's the angles that are at the bottom of that. Kind of looks like an angry face triangle. All right, so let's take that information to help us solve for these missing angles. So I know that 55 and W are going to be exactly the same. So W is equal to 55 degrees. So that one was easy compared to the other one that we're going to take a look at. For part B, I know that 3t plus 20 and 2t plus 42 have to be exactly the same. So now this becomes an equation where I have variables on both sides of my equal sign. So this is, again, where all of those skills that you learned when we looked at solving algebra are going to play a role in solving angles. So you can see how everything that we learn about in math builds on each other, right? It's all interconnected. So for this one, I have 3t plus 20 is equal to 2t plus 42, because these two angles are exactly the same, so they must equal each other. So now this is an example of an equation where we have variables on both sides, like I said. So I'm going to take my 2t first, and I'm going to move it to the left-hand side. Right now it's positive, so it's being added to the right-hand side. So when I bring it over to the left-hand side, I'm subtracting. So 3t take away 2t plus 20 is equal to 42. 3t take away 2t is 1t plus 20 is equal to 42. Now I'm going to take my 20 and I'm going to move it to the right-hand side. Right now it's being added, it's positive, so I'm going to subtract it from the right-hand side. So t is equal to 42 take away 20, or t is equal to 22. So now if I wanted to find out what each of these angles were, I would take this value of 22 and I would substitute it into these formulas. So let's take a look at what that would look like for this first one. So I have 3 times 22 plus 20. 3 times 22 is 66. And 66 plus 20 is 86. So this one is 86 degrees. Let's do this one in our head. 2 times 22 is 44, and 44 plus 42 is 86. So you can see that both of these are exactly the same, which is what we wanted. So if we solve this and they weren't the same, then we know we've made a mistake somewhere. whether that was in our solving the original equation, maybe it was in our substitution. So we'd have to go back and check our work to make sure that they were correct. And so the last theorem that you need to know before we go through some more examples is the equilateral triangle theorem. So this says that if I have a triangle, and again, we touched on this earlier, where all three sides are exactly the same, then all three angles are also going to be exactly the same. So this one, and this one, and all of those angles have a measure of 60 degrees. All right, so let's go through just some more examples so that you have this in your back pocket. So how do I find out what these missing angles are? So we are going to use all of those properties that we've learned about in these examples. So across from our 44 is angle B. So B is equal to 44. We use this, we use the opposite angle theorem to help us figure that one out. So I'm using not only the angle degree symbol in my question, in my answer, but I'm also stating the property that I used to solve for that. So now I want to figure out what angle C is, for example, or angle A, it doesn't matter. So if I look at angle A, these form a straight line. So angle A plus 44 is equal to 180 degrees. And that is our supplementary angle theorem. And now we're going to solve for A. So I'm going to move my 44 to the other side of my equation. So A is equal to 180, take away 44. And using the tools available to you, whether you're using mental math, you're using a calculator, you are sketching out those questions on a piece of lined paper, whatever works for you. So A is equal to 136 degrees. So now I can identify what C is. So C is directly across from A. So C is also 136 degrees, and we use the opposite angle theorem to decide that. So that's important to know. Okay, so let's take a look at this next one. So Y and 147 form a straight angle. So that's a supplementary angle. So I know that Y plus 147 is equal to Y plus 147 is equal to 180 degrees, and that is my supplementary angle theorem. So I'm going to solve for Y now by moving my 147 to the other side and subtracting. So Y is equal to 180, take away 147, and Y is equal to 33 degrees. Okay, so the next example is a right angle. So I know that when I have a right angle, and I've split it up into either 2 angles or 3 angles or whatever, when I add those angles together, it's going to give me 90 degrees. And that's our complementary angle theorem. So x plus 28 equals 90 degrees, and that's the complementary angle theorem, or complementary angles. So if you need to refer back to your sheet, you can. So complementary angles add up to 90, supplementary angles add up to 180 degrees. You have your opposite angle theorem. You have all of these things to refer back to if you need to. You're just starting this out, so I don't expect you to memorize these or have them memorized, but the more you do, the easier it's going to be for you. So now this becomes an equation that I know how to solve. So I'm moving my 28 to the other side, and I'm subtracting it. All right. So x is equal to 90, take away 28. or x is equal to 62 degrees. Okay. All right. So D is what we call a reflex angle. And so a reflex angle is an angle that is larger than 180 degrees, but less than 68 degrees, or sorry, less than 360 degrees. So I know that an entire circle, so we didn't look at this in our, but a circle is 360 degrees. So if I was to make a circle, then I would find this by taking 360 and I'm taking away 68. So that's what D is. So if you're looking for those, this is a reflex angle. If you're looking for a reflex angle, this is the strategy that I would use. So an entire circle is 360 degrees, and just take away the angle that you know. So D is equal to 360, take away 68, which is 292 degrees. And I've shown here that we've used properties of circles and the reflex angles here. So for the next one, again, these angles form a straight line. So B plus 50 plus 70 is equal to 180 degrees. That's our supplementary angle theorem. So B plus 120, 50 plus 70 is 120, is equal to 180. Moving over my 120 to the other side and subtracting. So B is equal to 180, take away 120, or B is equal to 60 degrees. Let's take a look at the next one. So right across from 44 is angle C. So C is equal to 44 degrees. That's our opposite angle theorem. B is 89 degrees. That's also opposite angle theorem. And now we have to solve for either A or D. So you can either use the straight line that is horizontal, or you can use the straight line that is on a diagonal to solve for A. It doesn't matter which one you do. Let's solve for A. So these ones equal 180 degrees. They form a straight line. So A plus 44 plus 89 is equal to 180 degrees. That's your supplementary angle theorem. So A plus 44 plus 89 simplifies to 133 is equal to 180. Let's move over our 133, subtract it. So A is equal to 180, take away 133. So A is equal to 47 degrees. And if A is equal to 147 degrees, then D is also 47 degrees because of the opposite angle theorem. And so last three examples, we're going to look at properties of triangles to help us solve for this. This is a scalene triangle, so none of the sides are equal. And we also know that every single angle inside of my triangle adds up to 180 degrees. So x plus 35 plus 110 is equal to 180 degrees. And if you need to refer back to your sheet to figure out what that's called, you can. So that is our angle sum of a triangle theorem. So ASTT is what you can simplify that to. So you don't have to write the entire theorem name. You can simplify that to ASSTT. So that's okay, you can do that. And now this becomes a equation that you can solve. So I can simplify my 35 plus 110. So x is equal to 145 degrees. Sorry about that, that's x plus. So x plus 145 degrees is equal to 180. I'm going to move over my 145 to the other side and subtract because it's adding to the left-hand side, so I'm going to bring it over. It's the opposite of that. So x is equal to 180. Take away 145. And 180 take away 145 is 35 degrees. And so we initially thought that this was going to be a scaling triangle, but we know that our hypothesis is actually wrong because I have two angles that are exactly the same, so then this ends up being an isosceles triangle. And so that's helpful for us to know as well. So sometimes we think that this is a scaling triangle based on what the diagram looks like, but our calculations prove otherwise. So that's kind of interesting to keep in mind. Now, this next example is actually an isosceles triangle because it's given to us that these two sides are exactly the same. And so I know that an isosceles triangle, that the bottom two angles are going to be exactly the same. So y is equal to 75 degrees. And if you can't remember the theorem, then just go back up to that page and refer to that. So that's perfectly fine to do that if you need to. So that is your isosceles triangle theorem. So ITT is what we simplify that as. And now we can use the properties of the angle sum of a triangle theorem to solve for x. So we know that x plus 75 plus 75 is equal to 180. So that's the angle sum of a triangle theorem. That's what we used in that previous example. So I'm going to add these up. So 75 plus 75 is 150. That's equal to 180. I'm going to subtract 150 when I bring it over to the left-hand or right-hand side. So x is equal to 180. Take away 150. So x is equal to 30 degrees. And this last example, we can solve this by using supplementary angles. So A and 126 degrees forms a straight line. So I have A plus 126 is equal to 180 degrees. That's your supplementary angle theorem. So solving for A is equal to 180. Take away 126. So A is 54 degrees. I can use the same strategy to solve for B. So B plus 145 is equal to 180 degrees. Again, that's the supplementary angle theorem. So solving for B, so B is equal to 180 take away 145. So B is equal to 35 degrees. So A, B, and C are the angles inside of a triangle. So I can use my angle sum of a triangle theorem. So I know that A plus B plus C is equal to 180 degrees. So that's the angle sum of a triangle theorem. So I can keep this like this here. I'm just going to move that up slightly. So I have a little bit more room. So I have So I can use that, or I can actually just substitute in what I know. So I know that C plus 54 plus 35 is equal to 180. I can do that as well. So C plus 54 plus 35 is 89, is equal to 180. C is equal to 180 subtract 89, or C is equal to 91 degrees. And lastly, you want to solve for D. D and C also create a straight line. I'm just going to draw a line through here. So D plus 91 is equal to 180 degrees. Again, that's your supplementary angle theorem. So D is equal to 180, take away 91. So D is equal to 89. And that is how we use those angle theorems to help us solve for missing angles. I know that was a lot of information to share with you at one time, so please feel free to rewatch this video more than once if you need to. Stop it, pause it, rewind it, whatever you need to do. If you have any questions, please put them in the discussion post or send me an email.